let's look at the solution for question 4. You are told that a wind tunnel draws air at atmospheric pressure 28 degrees centigrade, 101.3 kilopascals. If you look at the annotation in the solution that I gave you, there is a slight error. The solution is correct, but that annotation, just change it to 28 degrees rather than what you see there, 20 degrees. The large axial propeller fan is located at the exit of the tunnel, so air is drawn in and exits to the right. You are told that at the working section the velocity is 80 meters per second. Draw a sketch for this wind tunnel setup. What we have here is a simple sketch showing the wind tunnel, and it would be quite a simple task to draw, but please note that the fan is at the exit. It draws in air and expels it to the right. That's the only thing you have to be careful about. You have to determine the density of the air, okay, given the gas constant. So if we look at the solution, the density is the pressure multiplied by the gas constant times the temperature, okay, using the appropriate units. And remember, 28 degrees is 301 Kelvin. We get about 1.173 kilograms per cubic meter. Then we are asked to do a calculation after selecting a suitable streamline in the flow. Now, if you look at the solution, the streamline from 1 to 2 is taken, and we are supposed to calculate the absolute pressure at the working section. Okay, and in addition to that, of course, all the necessary assumptions. Now, the assumption for Bernoulli's equation to apply is the flow is steady, incompressible, there's no rotation within the flow, irrotational, and the friction is sufficiently small to be negligible, and that air is an ideal gas. We now take the point 1 at atmospheric pressure before the wind tunnel, as shown in the sketch, and we have all the parameters. P1 is atmospheric, and because V1 is sufficiently far away, you can say that it's practically equal to 0, very small. And the point 2 is in the wind tunnel. So in our Bernoulli's equation, we can say that Z1 or the elevation effects are negligible. So essentially Z1 equals 0 equals Z2. We are not going to consider Z at all. Now, substituting the appropriate values, because if you notice, we know what is V1, practically equal to 0. P1 is atmospheric. Z1 and Z2 disappears, so that we can now get P2 is equal to P1 minus rho V2 squared over 2. So remember, what we have to find is we are given the velocity at the working section to be 80 meters per second. Substituting appropriate values, density and pressure 1, we get a pressure, interestingly, less than atmosphere, which is 97.5 kilopascals. Okay, now the last part is quite significant. You're asked to discuss why sealing of the working section to prevent air leakages is an important design for maintenance tasks of this wind tunnel. Appreciate that the pressures within the tunnel is less than atmospheric pressure. If the ceiling is not good, there is a tendency for air leakage to come in that results in all kinds of turbulences, which will not be desirable when you are doing your work in the control environment of the working section of the wind tunnel. Okay, so the last part is interesting to note. The velocity increases at the expense of pressure. The pressure drops. Any leakages created during installation or maintenance will cause the outside air to enter the tunnel working section. Okay, we need to just put air to enter the tunnel working section. This will create cross flows and turbulences, resulting unreliable readings. This ends the solution for this question.